Good day everyone, this is Elisa Ann Guzmo starting the presentation for the Learning Activity 1 of Group A, where we'll add one data from our dataset from Performance Task number 1 and explain whether there was a difference when we solve once again for the measures of center and dispersion. Here we have the list of Group A's members, including their task for this activity, starting with Task A that is assigned to Kimberly Dador, Task B and Task C that is assigned to yours truly, Task D that is assigned to Maria Jonalyn Domingo, Gabriela Lagbang, and Camille Pama, and Task E assigned to Fiona Sam Katamora, Excel Computation assigned to Adrian Pascual, and Overall Explanation assigned by yours truly, and video and PPT editing assigned to Fiona Sam Katamora, and the video editing also assigned to Fiona Sam Katamora. Now moving forward, we have here on the screen the dataset from our performance task number 1 and also the added data that shall help us answer the question if whether there will be changes if we add one data on our dataset. Also, this added data was from Adrian Pascual, one of our members. Now for the tasks that we need to accomplish for this learning activity number 1, let's start with task A.
In the last activity, we collected data on the estimated daily phone usage of our blockmates. Now, using the data from the last activity, we are going to find the outlier. Here are the phone usage hours from our sample. There is 1 for 4 hours, 2 for 6, 1 for 7 hours, 3 for 8, 1 for 9, 3 for 10 hours, 2 for 11, 2 for 12 hours, 1 for 16, 1 for 18, 2 for 20 hours, and lastly 1 for 22 hours. To check if there's an outlier, we look at the most of the data. The majority of the values fall behind 6 to 12 hours, which seems like a normal daily phone usage range. However, we notice a few values that are much higher than the rest, like 20 and 22 hours. These stand out because they are far from the usual range and don't match the general pattern seen in the rest of the group. So even without using complex formulas, we can say that, yes, there are outliers in the data, specifically the values 20 and 22 hours, because they are unusually high compared to the rest of the sample. These outliers may show extreme cases of phone usage, and they remind us how important it is to look at all parts of their sample, not just the average.
For task B and C, just like with performance task 1, I'll do the explaining while Pascual does the Excel computation. So we're going to do the computation before we proceed with the explanation of whether there are changes in the measures of center and dispersion if one data is added. And in our case, that data is 6. With that being said, let's now start with the measures of center. Beginning with the mean, to get that we insert in the formula bar the formula of equals average, then dragging our dataset and our added data and then enter. And for everyone's information, the highlighted number is our added data. With that, it leaves us with the mean of 10.89473,684. Next that we're going to solve is the median. To get that, we insert in the formula bar the formula of equals median, then dragging our dataset and added data, and then enter. With that, it leaves us with a median of 10. Last, for the measures of center is the mode. To get that, we insert in the formula bar the formula of mode, then dragging our dataset and added data, and then enter. With that, it leaves us with the mode of 8 and 6. Now, before going all over our computed values for measures of center, let's first move forward to our second set of the same data, where we'll now solve for the measures of dispersion, which are the range, the variance, and the standard deviation. Let's now start with the range. With following almost the same formula for range, we're going to insert in the formula bar equals max for maximum, and then drag our data and added data minus min or minimum, and drag our data set and added data, and then enter. With that, it leaves us with a range of 18. Next that we're going to solve is the variance. To get that, we insert in the formula bar the formula of var.s, then dragging our dataset and added data, and then enter. With that, it leaves us with a variance of 26.988,30409. And for our last one is the standard deviation. To get that, we insert in the formula bar the formula of stdev.s, then dragging our dataset and added data, and then enter. With that, it leaves us with a standard deviation of 5.195026862. Overall, allow me to state the calculated measures of center and dispersion. For the mean, we have 10.89473,684. For the median, we have 10. For the mode, we have 8 and 6. For the range, we have 18. For the variance, we have 26.988,30409. For the standard deviation, we have 5.195026862. As compared to our first computed measures of center and dispersion, we had, for the mean, we have 11.16667. For the median, we have 10. For the mode, we have 8. For the range, we have 18. For the variance, we have 27.0882359. For the standard deviation, we have 5.204635943. So to answer the question, will there be changes if one sample is added? The answer is yes and no. For the mean, there have been a difference of 0.27193,316. For the median, it's stayed the same, remaining at 10. For the mode, it retained 8 and then added 6. There became 2 modes compared to just one originally. For the range, it stayed the same, remaining at 18. For the variance, there has been a difference of 0.0999312. For the standard deviation, there have been a difference of 0.009609081. So to conclude, there will be changes if one sample is added, but not entirely.
A political science student, I witnessed how descriptive statistics really relate to all the challenges that we experience in our daily lives. One of the relatable examples that we face, especially as political science students, are mental health issues. A lot of students experiences mental health issues due to being stressed, but a lot of them are afraid to speak up. Counselors often conduct a survey regarding this matter, and when we see the statistics wherein almost majority of the political science students struggle with their mental health, it becomes real, and it helps the counselor to think what would be their action to solve this kind of problem inside the university. Descriptive statistics can also be applied outside the educational setting, most especially in the barangay. For instance, a barangay captain requests cash for a feeding program, demonstrating that 50% of the children are underweight increases significance and credibility. These statistics represent the hardship of the Filipino families, especially parents who cannot buy their children nutritional foods and bring them to hospital for monthly checkups. Descriptive statistics could also help us understand how certain programs in our government could affect us all. One example would be the scholarship programs of the government. If the scholarship programs of the government proclaim success, we might inquire in our barangay how many students are able to earn scholarship or how many graduated from it. These statistics could help us determine whether these programs can really benefit the students or they are just merely verbal pledges. In conclusion, I have realized that descriptive statistics is more than just a number, and it is really related to our political science program because it helps us understand what is happening not only inside our university but also on the outside of our university. That is all. Thank you.
Descriptive statistics plays a big role in analyzing election data, helping us understand voters' behavior and identify trends. In an election with 1,000 voters, for instance, we can apply descriptive statistics to gain insight. We can calculate the mean voters turnout by dividing the total number of votes by the number of registered voters. Additionally, we can arrange voters' ages in ascending order to find the median age, which gives us a better understanding of a democratic characteristic of the voters. By analyzing the data, we can also identify the mode of voters' choice. For example, candidate A with 550 votes. This information can be presented in graphical representation such as bar charts, pie charts, or histograms to provide a clearer picture of the election result. In the context of my political science program, understanding descriptive statistics is essential in analyzing electoral behavior, identifying patterns and trends, and informing campaign strategies. This skill is also relevant to other areas of the study of political science such as public opinion, policy analysis, and governance. By applying descriptive statistics to election data, we can gain a deeper understanding of a democratic process and make more informed decisions as citizens and policymakers in the future.
As a political science student, I've come to realize how important descriptive statistics are, especially when it comes to public opinion and policy making. We often hear about surveys and polls in the news, but without descriptive statistics, that data would just be a bunch of random numbers. These tools helps us summarize and interpret public opinion clearly, like knowing how many people support a certain policy or what the average satisfaction is with government services. This matters a lot in politics because public opinion shapes policy. When leaders understand what people actually need or want based on solid data, they can create policies that are more effective, inclusive, and evidence-based. Descriptive statistics also help us track changes over time, spot problems like inequality, and evaluate whether a policy is actually working. It's a simple but powerful way to make sure that decisions are informed, not just based on guesses or assumptions. For me, learning how to use and understand descriptive statistics means I'll be better equipped to analyze political trends and contribute to meaningful change in the future. Thank you.
And that would be all for Group A's learning activity number 1. Thank you for lending us an ear.